Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 9, Section 4, Pythagorean theorem. And in this video in particular, we're going to be taking a look at how can we use the Pythagorean theorem, what can it be used for. And we're also going to take a look at one of the applications we're going to look at is how to use the Pythagorean to find missing sides of a right triangle. But we're also going to use it to figure out if you actually have a right triangle. Okay, you can use Pythagorean theorem to test the side lengths of a triangle to see if it is in fact a right triangle. But the first things first, we're going to start with the missing pieces bit. If you have a right triangle, okay, you have sides A, B, and C, and the formula, or the Pythagorean theorem, is a squared plus b squared equals c squared. So if I square the two legs, add them together, it should be equal to the hypotenuse squared. Okay. So how can that be useful to us for finding missing sides? Well, if you're given 2 out of the 3 sides of a right triangle, then you're more than capable of finding the third side, but you need 2 out of 3. So for example, if someone draws me a picture of a triangle, says I have a side of 3 and a side of 4, what is the length of my hypotenuse? Then you would plug in 3 squared plus 4 squared equals c squared. And now we can solve this for c and figure out what that missing side is. So we would square 3 and get 9. We would square 4 and get 16. And there's nothing we can do to c squared right now. At this point, I would want to combine the 9 and the 16, and I would get 25 equals c squared. We're not done yet. Okay? We want to know what the missing side is, and the missing side is c. Okay? This is c squared. This is different. So we need to get rid of the squared, something that we've toyed around with a little bit in the previous sections. So the concept here is, how do you undo something that is being squared? Well, when we had to undo addition, we subtracted. When we had to undo subtraction, we added. We did opposites, right? Opposites undo each other. When we had to undo multiplication, we divided. When we had to undo division, we multiplied. Well, the opposite of squaring something is square rooting something. And now, again, that was explained in a previous section here. So I'm not going to go into the details, any more details than this. The opposite of squaring is square rooting. So you would square root both sides. The c squared would turn into c. The square root of 25 is 5. And so you'd find out that your missing side is 5. Now, just as a heads up, okay, this right triangle has sides of 3, 4, and 5. That does not mean, and I am clarifying here, so make sure you're paying attention to this, that does not mean any triangle can be, right triangle can be written like this. 5, 6, and 7, those are not accurate sides for a right triangle. 5 squared plus 6 squared does not equal 7 squared. This is just a coincidence. Okay? If you take a look at this triangle, okay, and you want to test it out. This is what I was talking about earlier. If I want to test out, is this actually a right triangle? Are these side lengths they gave me accurate? Test it out. Plug these numbers in. 5 squared plus 6 squared. Does it equal 7 squared? Okay, let's find out. Does 25 plus 36 equal 49? No. That is not true. Therefore, these are not accurate side lengths. You cannot have a right triangle with a leg of 5, a leg of 6, and a hypotenuse of 7. It is impossible to have a right triangle with those dimensions. Okay? As we discovered before, though, we can have one with 3, 4, and 5. Okay? So I'm going to use the same example, the 3, 4, 5 right triangle. But now I'm going to give you the hypotenuse. And I'm going to take away one of the legs. Okay? And so it doesn't matter which piece of the triangle is missing, you can still find the missing piece. Now in this case, Okay, the hypotenuse is always C. And the legs are always A and B. A lot of people interchange the A and B. Doesn't matter which one's A, which one's B. I always like to put A up on the top piece. But the hypotenuse here is always your C length. Okay, is always by itself over here. It's always C squared when you're plugging things into your formula. So then we would have 3 squared plus B squared. Okay. So again, I'm going to solve what can be solved first. 3 squared is 9. B squared I can't do anything with. 5 squared is 25. I want to get B alone. That's my goal. I want to know what B is, so I got to get rid of the 9. So I'm going to subtract 9 from both sides. Okay, I'm left with B squared on the left side. And I'm left with 16 on the right side. To get rid of something that's being squared, because again, I want to get B alone, got to get rid of the power of 2. To undo something being squared, we square root. And the square root of 16 is 4, so B equals 4, just like it was before. Okay? But you need to pay attention to your dimensions. Okay? Which piece is missing? Which pieces are given to you? How do you plug them into the equation? A squared plus B squared equals C squared. Hypotenuse is always C squared. Okay? Hypotenuse is always represented by the variable by C. Okay? The other thing to be careful of too is sometimes, okay, typically you see your right triangles given to you like this. Sometimes they'll try to flip the triangle, so maybe you'll see it like this. Okay? In this case, your C is in a slightly different position, so you need to be aware of that, especially on some of these standardized tests. They like to give you triangles like this. They're trying to trick you. They're trying to get you to use one of the legs as the hypotenuse. You got to pay attention. Where is that hypotenuse? Wherever that hypotenuse is, that's C. Where A and B are, as long as you are 100% confident, this is my hypotenuse, this is C, doesn't matter what you choose for A and B. Okay? You can choose whatever you want for A and B. It doesn't matter. Okay, but always find the hypotenuse first and label it with C. After that, the other 2 legs that are left, okay, label them A or B, doesn't matter. So again, you might be given triangles like this with labels on them, okay, and you might have to find the missing piece. But you also may be given something. They might say, you know, side A equals 3, and they'll say side B equals question mark, and side C equals 5. Find the missing side. Okay? So same basic concept, just instead of giving it to you in a picture form, they've given it to you out like this. You'd still plug in 3 squared plus B squared equals 5 squared and go through the same process. Okay? So that's really all there is to Pythagorean theorem. I think real quick before I end the video, I'll just go over one more time. If you're given the side lengths of a right triangle, such as, let's go with 6, 10, and 12, and you want to test out, is this really a right triangle? Are these side lengths accurate? Okay, test it out. Here's the legs, so 6 squared plus 10 squared. Does it equal 12 squared? Okay, 36 plus 100. Does it equal 144? No, it does not. That is not a right triangle. Okay. So again, fill in the pieces you know. All you're doing is you're using the formula. A squared plus B squared equals C squared. This is Pythagorean theorem. Fill in the pieces or information they've given you, and then use that to find the information they did not give you or that you were looking for. So, next video will be on Chapter 9, Section 5, distance formula, which is actually very heavily related to Pythagorean theorem, and we'll talk about that in the next